My name is Dave Bermingham, and hope you're here for the session on surviving the next Azure outage like a boss. I'm a senior technical evangelist for Silos Technology. We're an exhibitor here, so if you have any questions, I'll stick around after the session, but I'll be at our booth all day as well. Silos Technology is a software company focused in high availability disaster recovery. So for the past 16 years, I've been able to focus most of my energies on high availability and disaster recovery concerns. So helping customers deal with those issues. And then most recently, probably in the past 5 years, most of those customers are now in the cloud, whether it's Azure, AWS, Google, whatever it might be. So it's kind of like my bread and butter of what I do on a day-to-day basis at Silos Technology. Of course, silence your cell phones, explore everything PaaS has to offer. I do speak at a lot of like SQL Saturday events. So if you've ever seen me, I've been at plenty of those events. I'm doing a couple user group meetings. So if you haven't gotten out to any of your local user groups, definitely it's a wealth of knowledge, and it's usually a good time. And then the SQL Saturdays, if you haven't attended a local SQL Saturday, take the time to do it. And it's great training for no cost. This is all my contact information: LinkedIn, Facebook, Twitter, my blog. I would point you to my blog. All the demos I'm going to do today, I'm going to post on my blog, and I'm going to record some audio over them as well. So you'll have everything, plus all the code examples. They'll be on my blog later today. I blog mostly about high availability disaster recovery and a lot of stuff about Azure and other cloud platforms. I've been a Microsoft cluster MVP for 10 years now. I started out as a cluster high availability MVP. Now I'm a cloud and data center management MVP. But that's a great program. It gives me lots of insight into what Microsoft is doing and the team behind the scenes. Don't forget to fill out your session evaluations. Submit by Friday to win prizes. So this is what we're going to talk about. It's kind of a big topic, and there are a lot of little topics within it. So I'm going to cover as much material as I can. And again, try to hold your questions to the end, and I will stick around and answer all those questions. So we're going to be a brief history of outages. What are the risks and liabilities? We're going to talk about the SLA that the cloud providers offer. How to mitigate the risk. And then we're going to look specifically at what are my high availability options, what are my disaster recovery options, and then we'll wrap it up. So a brief history. So you can go on at any time to the Azure Portal and get a list of outages. So I just copied this from when I submitted this slide deck 30 days ago. These are what Azure has published as, these have had some downtime. So you can always get the most recent information about what's going on. It's not always up to date. Like you might be experiencing an outage, and we're going to be talking about an outage that happened almost 2 years ago now, that the actual portal to get information about the outage wasn't available. And so we were getting most of our information via Twitter early on. It's like people are like, hey, I'm down. Yeah, I'm down. And so you kind of piece the puzzle together, like, yeah, things are going bad. And then Microsoft has a Twitter account as well. And they publish information. Like, yeah, things aren't going so well. The outage I was talking about is the September 2018 outage from South Central region. And I was planning on talking about this, but I have a special guest that offered to go through this from a Microsoft perspective because his name is Kenny Pontamp. So Kenny's going to come up, and he offered to go through this from a Microsoft perspective because he was actually handling from the inside this crisis.
Okay, let me get that. So this is part of a session that we did in a sister conference of my product. And we changed the title to something boring and then something with lightning because it was giving more customers to the session. So this is me. I'm a program manager and incident manager in Dynamics 365 Business Central. And I was on call as incident manager for this particular outage. Just as always, don't trust anything I say. That's the legalese for that. Okay, so I know where I was when lightning struck. So what's your name?
Dave Bermingham.
Dave. So
Yeah.
Dave was talking about the root cause of this was lightning storm took out coolers in a data center. That's where it all started. Where it started for me was around noon. Our on-call engineer started to get a flood of severity 2 incidents from our alerting. And I was actually at the dentist with my son. He was not happy about that, 8-year-old. So the only way I could make him stay there was bribe him with ice cream. So that's what we did. And I was sitting at the ice cream bar with him before he was heading back to school when I got a call. And my engineer told me something is not right, this is not good. So what he told me was that this is the control plane and runtime plane for our service. And in here, this is the kind of runtime we have, the data plane, lots of microservices, and we're getting alerts from these that it was not very good. And the kind of alert we get is this is similar to Azure Monitor, but it's just the internal thing, the thing we built for Azure to run Azure that you can now use in, I think, App Insights, it's branded now. So this is a monitor, and you can see it's kicking in with a low, in this case, low memory alert, but in the particular case, it was like we're not getting any health signal at all. And then this creates what we call an ICM ticket. This is one of these with a severity and then with some ways to actually go in and see into the system the health of that. And then these can auto-mitigate also if things are just transient. So and this is what we call Geneva metrics and monitors, and that's what's part of App Insights as a product. So you can also do this and set up monitoring for your services in Azure. So we found out, first of all, with an internal email instead of Twitter. But then the Azure website was actually updated later to the status to see that everything you can see, green is good, red not so good. And that was a severity 1 ticket. Can I just need to here. So inside Azure we have these different severity levels. Severity 0 is what we reserve for zombie apocalypse, losing if a meteor is hitting the US and US is gone. So we never use that. One CSS engineer did that once by mistake because he thought or she thought it was getting more attention to go severity 0. It does. It means that Satya will get a call. So we don't do that. Severity 1 is a regional. This is where we go when we lose a region like that. And that's what a severity 1 incident was. Yeah, you know this. So the way everything in Azure works is that we have an on-call rotation of engineers and incident managers, different roles. Incident manager is kind of just not fixing, but making sure that we are on top. And then we have engineers, and we always have a member of our leadership team on call as well in case we need to take important decisions. Then I showed you an ICM ticket, and by the way, this ICM ticket system is not running on Azure. I mean, we need to make sure that that is up and running when Azure is not. Then we have a thing internally called a bridge. It's basically just a Teams meeting where we can now connect and talk about what's happening. And we can, instead of everyone panicking, this is the way we deal with questions like, and this is, in this call, this is where I saw people like Connor Cunningham writing, Azure SQL status, and like CVP level and engineering are collaborating on that Teams call to make sure that we get things up and running. And then we set up a special monitor to actually see whether we were getting signs of life. And in this graph here, you can see that around 12, all the VM CPU counters go to 0. I don't know what this guy is, very persistent, or I don't know, probably an error. And then around 6 o'clock, we're seeing the first signs of life of VMs getting online. but not necessarily the databases. And then we switch at midnight to an incident manager on the West Coast because I cannot keep working. I need to sleep to take decisions. And then Azure engineers work through the night to restore first power, cooling, fabric. Fabric is not service fabric. And then compute. And then once compute and storage is up and running, then it's time for Azure SQL to be able to get databases online and rolling the transaction log back and making sure that databases are good. Next morning around 10, we start to see our clusters be back and running. This is the actual status from my email that we have signs of life, and the way we know that is through Kusto. Kusto is the query language we use and you can use in App Insights to query telemetry. And this is a Kusto query from our telemetry saying, with a special tag saying, and this tag is saying successful customer login in our portal or client, and then like within the next last 7 days, we could then see, okay, we can now see from telemetry then customers are able to log in, and we could mitigate the situation, and that's pretty much it. And then for everything we do a post-mortem and make sure that we ask the questions, how can we improve our processes, our technology, our alerts and monitors, and the way we work together. And that typically goes into a post-mortem report, and this is the one that was on our side, but the one on Azure, the data center outage, this is not accessible for you. This is just our internal ones. But the one from the outage, you can actually go and download the root cause analysis and go and read yourself. And I guess that's what you did, preparing for this. And I think that's from the insider. That's what happens from within Microsoft, within Azure, how we deal with an incident like this. Back to you.
Great, appreciate it. Thank you, Kenny. So that was a unexpected treat. We got to hear from the Microsoft themselves of what that incident looked like inside, and their response, and as Kenny was saying, the incident report and what they have done moving forward to avoid similar problems in the future. From the outside, what we gathered when it was happening, like Kenny was saying, there was storms in the area. Took off chillers. The redundant chillers were offline and didn't come online automatically. So that doesn't happen anymore. But it caused everything inside the data center to heat up. And so everything shut down hard. Servers and storage and networking and the whole South Central region failed. And there were other resources dependent upon resources running that region. So you might have had outages from ASM to ARM to Azure Active Directory, Visual Team Services was offline. So there was more than just, you might have been impacted even if you did not have any resources hosted in the South Central region.
Can I say one more thing?
Yes.
The reason why it's super dangerous to lose cooling, you know why? Any idea?
To lose cooling?
To lose cooling, of course, not bad, not good for equipment. Actually, the temperature, when you shut off the power, the temperature for cooling the devices that are at the hot they are and how they cool the air, when they are turned off, it will take around 90 seconds for the room temperature to rise to around 70 degrees Celsius, which is dangerous, like to a level where it's dangerous for a person to be in that room. So it's not only about equipment, it's also about lives of engineers working in that environment. Yeah.
Great. So the good thing is no one lost data. So, and that was, I think, probably primary concern is always, if you can preserve the data, preserve the data. Now, some people say, well, I had my data in geo-redundant storage. So, what about that? And when can I make that replica the actual active node and say, I'm okay with some data loss. I really need to get online. So let me just, roll with what my geo replica has. And you could get a read-only copy of it and maybe work with that. But I know one of the responses was Microsoft is giving you the ability to actually make that call. It's like, you know what, read-only replica is now going to be my source. And so that's still in preview, I believe, right? To be able to do that with the storage replica. Yeah. So that's one of the steps that Microsoft's taken to avoid those things in the future, is to give you more control rather than Microsoft saying data protection is number one. Yeah, I know you've been offline for 2 days, but we didn't lose any of your data. You might have said, well, I rather would have been offline for 2 hours with some data loss. Now you have that option if you're using the geo-replicated data like that. So just because you're moving into the cloud doesn't mean that you give up all the risk and liabilities of managing your own data center. You still have to deal with storms and floods and natural disasters and everything that goes along with that, including the power outages, whether it be, a whole region or just your data center or just a specific rack or a specific server. There's always a chance of losing power. Human error, and we see this happen on, it's not unheard of for someone to have a whoops moment that brings things offline, and it can be pretty drastic, from just updating some routes, or updating some firmware or whatever it might be. And so we're going to talk about how Microsoft specifically tries to minimize the impact even of human errors by using what's called paired regions, and we'll talk about paired regions. But then also you have risk from attacks from outside, so data breaches or data loss or insider threats, denial of service attacks, Spectre and Meltdown. So all these things are risk and liabilities you still have even though you're in the cloud, and you need to take these into consideration when you're developing your business continuity plan, your disaster recovery plan. So again, going back to, it's like, well, Dave, I thought, I'm not in the business of managing the data center. Microsoft says, hey, we have a 99.9 something SLA. And so it's like, well, I'm just going to run my SQL in a virtual machine in Azure, and it's good, right? We have to read the fine print of the SLA, and this is not unusual. This is not specific to just Azure. Most of the cloud providers have a very similar SLA, where they will guarantee some level of availability, but you have to take some steps. And so written right here is talking about availability zones, and if you deploy your virtual machines in 2 different availability zones, they're going to guarantee that at least one of those virtual machines is going to be available 99.99% of the time. And then when I say available, it's going to be reachable from the outside world. Doesn't say anything about the applications running inside that virtual machine. You still have to take steps to ensure the availability of your workload. But from the virtual machine aspect, if you deploy across 2 availability zones, Microsoft's going to guarantee that at least one of those are available. Before availability zones started becoming available in Azure, and we're going to talk a little bit more about availability zones and exactly what they are, but they had something called availability sets. And if you used an availability set, you would have 99.95% SLA, which doesn't sound like a lot, but if you do the math and how many minutes per year, really high availability is generally considered to start at 4 nines. So if someone said, I need a highly available SQL Server instance, you're going to want to really shoot for availability zones if it's available in your region to get you that 4 nines of availability. If you deploy in a single instance, it's not awful. Microsoft's going to guarantee you 99.9% availability, and that might just be fine for some workloads that aren't super critical, that can deal with some downtime. The problem we saw in the South Central region was, at the time, there was no availability zones for that region. So if you were in that region, and even if you thought you crossed your T's, dotted your I's, and you were using availability sets, well, the whole region was offline, so even using availability sets was not going to save you. Availability zones, if you were using them at that time and you had things configured properly, failover, you might have fared a little bit better in that particular outage. So jumping into availability sets, and what exactly is it? So this has been around in Azure since the beginning. It's called availability sets, and it's used for high availability. And so what happens is when you create a VM, and I have a demo that shows you, you can choose to put VMs in a same availability set. And by putting all your VMs in the same availability set, it distributes those VMs across what's called fault domains. So we see across the top of the slide, FD0, FD1, FD2. There's a max of 3 fault domains with any availability set. So if I were going to build a 2-node cluster, I would want to put my 2 nodes in an availability set. And that basically guarantees that one node is going to run on FD0, another node will run on FD1. And what these fault domains are really, you think of like a rack of servers that are totally independent of the other racks of servers. So they don't share the same power or networking. So there's some redundancy there. And then within the fault domain, you have individual physical servers. So you have to think of a rack, right? You have a rack, and then you have multiple physical servers in a rack. So those physical servers is what I would think of as update domains. So the difference between a fault domain and an update domain, obviously update domain, you can have many more because you have multiple servers per rack. And what an update domain does for you is Microsoft, when they're doing any updates that might incur some downtime, they will only update one update domain at a time. So if they're going to do an update that is going to cause your server to go offline, if you've done your homework and you've configured some availability, which we're going to talk about, your instance should fail over to another instance that is not being touched, because Microsoft said we're only going to update one update domain at a given time. So this is good. If you deploy like this, you're going to get that 99.95%. This is available in all regions. And so let's jump into a quick availability sets. There we go. So just a quick show of hands. Who here has never deployed a virtual machine in Azure at all? All right, cool. So this doesn't show me anything new. Just going to point out where you see this when you're deploying your instance. We're going to just deploy a 2016 machine, and you pick a new resource group. We get down, we give it a name. Pick a region. A region's important when you're picking availability because not all regions support the 3 options you see here, the availability zones, the availability sets, and a virtual machine scale set. So US East 2 supports it all. So for this demo, we're going to choose an availability set. So this first machine, I'm putting in an availability set. The first time you have to create an availability set for the very first instance. So we'll go ahead and create a new availability set. Give it a name. You'll see by default, it gives you 2 fault domains. And I'm going to turn this up to 3, and I'll tell you why. Who here has ever built a failover cluster instance or an availability group? Okay. So there's a concept of cluster quorum. And so you're going to need an independent witness that is going to be a vote in your cluster. So if you have a 2-node SQL Server cluster, imagine this. Server A, server B. If you have a simple network communication glitch between the 2 servers, well, without a witness to decide which one is actually live, you might have split brain, where the backup server says, I can't talk to the primary server, I'm going to come online. The primary server says, backup server's offline, I'm just going to keep working. 2 active servers, and that's a no-no. So you have a 3rd witness. It can be a file share witness, could be another server that hosts a file share that acts as a witness. Could be a cloud witness, which we'll talk about. It's simple using a storage account in Azure Witness. Or in a traditional shared storage cluster, it could just be a small disk, and it would be a disk witness. But by choosing 3 fault domains, if I want to add a witness server, I would put my witness server in the same availability set, and that guarantees that if any one fault domain fails, it should only impact 1 vote in my cluster. So I want to make sure if I'm using that file share witness to put it in this availability set as well. So we'll say OK. And that, so move forward. So that was the first one. Create this virtual machine. Jump ahead a little bit here. We'll need to see all of this good stuff. Okay. And here's the, so here's the next machine. So when I go to create the next machine, you'll see that the availability set is going to be available for us. So we'll just add it to the same availability set. There it is. So that's the SQL cluster is what I created the last time. So I would just go through the whole process and put all my nodes in that cluster. And once it's all done, you can, if you go back and look at your virtual machines, this is the third one, so I'm going to put the third one in as well. Jump forward a little bit. So if you want to have a look at what's going on, you can view your availability sets. Here's the 3 virtual machines I put in this availability set. You can see they list default domains and update domains. So it's good, all 3 of my servers. In this particular case, my 2 SQL Server nodes plus my domain controller are going to be in the same availability set. All right, let's move on here. So availability zones. This is by far the better option. This basically, in some regions, not every region, but more and more regions are coming online all the time, but some regions will have multiple data centers in that region. And those independent data centers are called availability zones. And by deploying your instances in different availability zones, actually physically different data centers, in the case of the South Central outage, if the chillers took down one of those availability zones, 2 other availability zones should still have been online, and you should have recovered a lot easier with no data loss if you're doing any sort of synchronous replication. So this is by far, if you have the option, I recommend you use the availability zones. So we'll jump into a quick demo on availability zones. I don't believe so. I don't think there's a price difference between zones and availability sets. So same idea when you're creating your instance at the point where you have to choose your availability options. This time we're going to choose availability zones. So again, it's very important. If you don't see availability zones in this drop-down list, it's probably because you picked a region that doesn't support availability zones yet. So make sure you do your homework. You pick a region that has availability zones. You pick the zone. So you manage this on your own. You have to actually decide which zone you want to use. So you got to make sure your instances reside in different zones, or if you have a witness, that it's also going to reside in the 3rd availability zone. So jump forward a little bit here. And again, so you would, for the 2nd server, same idea, create your server, and then you're going to put this one in AZ2. And we'll jump forward through this. At the end of the day, if you want to see what AZ your server resides in, you're going to have to add that column so you can see it listed nicely next to your virtual machine. So we're going to choose availability zones, add it to some of the columns we like to see, and then there it goes. So now you can see your availability zones associated with each of your virtual machines. So at this point, we're just talking about the infrastructure. We haven't talked about what we need to do now that I have my virtual machines running in different AZs or different fault domains. That's kind of what's coming up next here. So regions. You might think that availability zones, now that solves my problem, and that may be as far as you want to go. But we did talk about more catastrophic type failures, and availability zones, when they're built out, they're built out so that they should not be impacted by the same flood or the same power outage. So there is some resiliency within those availability zones, but at the end of the day, if you have huge wildfires that are just burning through your state, like we've never seen that before, right? You could impact multiple availability zones in a single region. So you might, for disaster recovery, want to pick in a different region entirely, Or you might want to pick your own data center, as kind of a fail-safe, or whatever you want to do. But you typically want to have that fail-safe option. So you're going to want to pick another region. And so what Microsoft has done, which I think is awesome, and this is, I don't know of any other cloud provider that does this. They have something called a paired region. So for every region, Microsoft has a paired region. You might call it a sister region, whatever it is, whatever you want to call it. But it's kind of a recommended region that you utilize as your DR site. If you're configuring multi-region for DR, then you're going to want to use the paired region that Microsoft recommends for your region. And that paired region is typically in the same country, whenever possible. It's in most cases. I think there's maybe one exception. And what a paired region does, so I mentioned earlier about those update domains, that Microsoft will only update one update domain at a time, and that's in Iraq. But sometimes there's regional type updates that have to happen across the entire region. So they will make sure that they only update one region of a paired region. So if things go horribly wrong, your paired region is unaffected. In theory, you should be able to fail over to it and keep running if you've done things right. So they isolate for system updates. And if there were some crazy failure that just brought multiple regions down, more likely human error, or some nefarious attack of some sort, right? Microsoft's going to prioritize at least one of your paired regions for recovery. So instead of just like running around trying to do everything, they're like, here's half of the regions we need to get online ASAP. And as soon as we get them, then we can deal with the other half, right? So they kind of, again, if you've done your homework, then you can be sure to take advantage of that if that ever happens, right? There's some, the region pairs will have some space between them. So again, hopefully avoiding the same natural disaster. And so that's region pairs. So now we talk about, so now I have multiple regions. I got to do something to make those regions talk, right? If I'm going to do any sort of replication, and we're going to get into like building availability groups or using Azure Site Recovery or whatever it might be, you want to be able to get data out of one region to another, and you want to have networking between them. So Microsoft made it super easy. There's a few ways to do it, but VNet pairing by far is going to be your best option if you're doing any sort of real-time replication between regions. This is going to be your highest speed, lowest latency type network connection. So you're going to want to set up a VNet pairing. VPNs, gateways are another option, but not so great when you're talking about replicating data across those. So quick demo, because it's pretty simple compared to what it used to be. If you ever had like configure routers to connect, I knew enough to be dangerous. It was always hard to, let me look at this. Hybrid cloud, here we go. I think this is it. Wait. Yeah, peering. Okay. So in this case, I have my domain controller and 2 SQL servers all in US East 2. Now I want to add another server to Central. For US East 2, Central is its paired region. So I'm going to create a server over there in Central. So we'll create a new virtual machine. So again, we'll just put the same resource group, give it a name, SQL 2 or SQL 3. Region, I'm going to pick the Central. There we go, Central US. Now, redundancy. Now, because it's a different region, I can't put it in the same availability set, right, if I was using availability sets. And the availability zones are fine. This region has its own set of availability zones, so we're going to put it in one of those availability zones, but they're separate from the availability zones I already set up. And now, as part of that process, I created a new virtual network. And here's the virtual network that we see, the 2 that we need to connect together now, the East and the Central. So it's really, really super simple. You go down here to the peerings, and you add a new peering. You give it a name, whatever you want to call it. Select your virtual network. There we go. So I'm connecting the east network to the central network here. In the past, you used to have to kind of do it both ways, but they've simplified the process. So you only do it once, and the peering is configured for you. So I think that's about it for the peering. Yep. So again, very simple. You don't need to be a network engineer, no Cisco routing or anything like that. You just click a button, and now your two regions are networked together. Very simple. Okay, so now we've built the infrastructure. We have our virtual machines up and running. We got the network configured. We understand our paired regions, and so we're ready to go. So the first thing we were thinking about, well, we need to provide some high availability. We've got to keep this thing online. And just to backtrack, we're talking about running SQL Server in infrastructure as a service. We're not talking about managed instance. Managed instance has this, they take care of this for you, right? We're not talking about any platform as a service, Azure, SQL, nothing like that. That has options for availability. It's just a checkbox, pay the money, and you hope that it's available. But if you're managing your own infrastructure for whatever reason, these are the steps you need to take, right? So what are your options? You dig into the documentation, look at high availability, and then immediately jump into availability groups. So if you're familiar with SQL Server, you've probably heard of always-on availability groups, which would be one of the options for configuring high availability between two or three instances that we're talking about. So we're going to jump in. Again, I could do a whole class, and there probably were whole classes on availability groups during the week here, but we're going to go through I'm going to point out how availability groups are different in Azure, because they're very similar, but there are some nuances, especially when it comes around to the listener, creating the listener. So if you're familiar with availability groups, just bear with me, and I'll point out where we are going to talk about how it's different in Azure. So again, it's going to be real quick, so hold on to your seats. The first thing you want to know is when you're configuring your SQL Server service, you got to make sure it's running as a domain account on all your SQL instances that you want to configure the always-on availability groups. So create your domain account and make sure your service is running with that domain account. We'll use that later when we are configuring things here. So I created the SQL Server service account. I'm going to run that on all my instances. Let me jump forward here. Okay. So who here is not familiar with always-on availability groups? All pretty familiar. Good. You know that it uses failover clustering as its framework. So you get on all the nodes that you want to participate in the always-on availability groups. They got to be in the same cluster, so you can install the cluster tools here through PowerShell, or you could use Server Manager, whatever makes sense to you. So we get the cluster installed on all the nodes, and then the next step would be to get them going. Let me jump forward a little bit. You want to test the cluster. So after the cluster is installed, you're going to run a test cluster, and that runs the cluster validation. So the test cluster has to come back clean with no errors. And you might get some warnings, and so the warnings will be reported in the test report. I'll show you the link here. The test report looks something like this. The only warnings you should really receive are in regards to networking, because we're dealing in Azure. We're only going to talk about one networking pair. And then also, you might receive warnings about storage, because we don't have any shared storage typically required for a cluster. You can ignore that. Sometimes there's some missing updates, so make sure you get all your updates the same on all the cluster nodes. You need to make sure you have a clean validation run, otherwise you don't have Microsoft support. Once that's done, you can create a new cluster. Again, command line works great. I would say it's actually required in Azure to create your cluster via command line, because your machines are using DHCP and you can't change that. If you tried to do this through the GUI, you would get a duplicate IP address for your static cluster IP address. So you must create your cluster through the command line specifying the static IP address and no storage, because we're not using any storage for availability groups. All right. So this warning here is just telling us, hey, there was no disk found. That means we don't have a witness configured. So we're going to have to configure the witness next. So that was the warning was after the cluster was created. So we're going to use a file share witness. I'm sorry, a cloud witness. So the first thing you do in Azure is just create a storage account. Give it a, put it in a resource group, give it a name. Of course, the name has to be unique. The big thing here is the replication of this storage account. You don't want geo-replicated. They don't support putting Cloud Witness on any geo-replicated, so just locally redundant storage is fine. We pick that here. There we go. Pick it, there we go. So create the storage account. Once the storage account is created, jump forward a little bit. Storage account's created. You go back in and you're going to copy the name of the storage account, but more the access keys is really what you need. So the storage account will have these access keys. Copy that to your clipboard, and then when we go to create the Cloud Witness, we'll use the name and the key for the Cloud Witness. So again, you can do this through Cluster Manager. This is a simple PowerShell script to set the cluster quorum using a Cloud Witness. You see the account name I just created and the access key to that account is all part of this code. And so that just set the Cloud Witness for the cluster. So we built the framework, the failover clustering framework. And now, to get always on going, you have to enable it. So if, in the properties of the SQL Server, you enable failover clustering. So right here, you right-click on it. Well, after you enable it, you have to restart it. Do that on all the servers. Enable the always-on availability groups. So jump forward, since most of you guys have done this before. Again, so just keep that going. And then, so once it's enabled, you're going to have to create a repository, a shared folder that all the nodes can access, that the SQL Server service account can access. So I created this folder. It gave the SQL Server service access to it. So when we go to create our availability group, all the servers can write and read to that location. Let me jump forward here. All right, so here we are in the, the other thing is, of course, you have to make sure every database that you want to protect has been backed up at least once. And then, so here's the wizard. So you walk through the high availability wizard. Now, this is where it begins to become a little bit different. You're going to give it a name. You're going to select your databases and your replicas. But the one thing you're not going to do that you might normally do at this point is create your listener. You're going to create an availability group without the listener. And we're going to go back later and add the listener. And you have to do it in those steps. Otherwise, this listener's not going to work properly. And this is all pretty well documented. Microsoft documents this pretty well, this process, so don't think you need to remember everything you're seeing here. Again, this is all standard, always on availability groups. We're going to, we have our SQL Server 1. We're going to add SQL Server 2, add a replica, SQL Server 2. And in this case, I think we're going to add SQL Server 3 as well. So between SQL 1 and 2 in the same region, we're going to do synchronous replication with automatic failover for high availability. And then we're going to add that third node, SQL 3, in the central region, and we're going to leave that with asynchronous. So asynchronous lets you replicate greater distances across higher latency networks without any performance overhead. So we set up those replicas, and let's jump forward. So you notice we didn't do any listeners. So let the replicas create. Now we'll jump over here. Before we create the listener, let's talk a little bit about client redirection. And this is unique to Azure. Normally, in any cluster, you have a name and a virtual IP address, and you configure your clients to connect to that name, which resolves to that virtual IP address. And that address moves between the cluster nodes, and your client reconnects to whichever node is online. Now, because Azure does not support gratuitous ARPs, that virtual IP address is not routable. So you need to do something to make it work. And in Azure, what that is we're going to create a load balancer, an Azure load balancer, that is going to probe the 2 nodes in my cluster, or in this case, maybe 3 nodes, or however many nodes are in your cluster, will probe the cluster nodes, and it will look for a health port, which we're going to add in a moment here. But basically, your clients connect to the load balancer. The load balancer decides which node is online, and will redirect the traffic to that node. So these are the additional steps you have to take in Azure that are unique to Azure. So we'll start with the load balancer. Because we're using I think these are in availability zones, we're going to create a standard load balancer. Here we go. Internal, and it's going to be internal load balancers because we're going to redirect it to the internal network. Static address. Now take note of this. So we're creating an address of 10.0.1.101. Don't forget that, right? So that's unique for that subnet, and we'll see it again in a moment here. But it's a static address associated with that router. It's 101. So we created that load balancer, and once it creates, again, a lot of this I've sped up, so you're not waiting for things to create here. So we have that load balancer, and then we're going to go into the load balancer. Actually, we're going to create another load balancer for the other end. So this is where it gets even just a little bit more confusing, because you have 2 load balancers. You have one for your East Coast that has 2 servers in it, and we're going to create one for the central region, but it only has 1 server. Saying, well, why do I need a load balancer with 1 server? You still can't communicate directly with the virtual IP address of that 1 server, so you need to have a load balancer in front of it. So we're going to create that load balancer as well. And you notice here for the private IP address, again, it's going to be an address that we're going to use again in a future step here. So you see 101 here for that particular subnet. So we got 2 load balancers created. All right, so that's cooking. We'll jump forward. And here's the load balancer we just created. So first thing you do, we're going to check the front end IP. That should have the IP that we created. And then we need to add the backend pool. So here's where we add the servers that we want in the load balancer. So we'll go ahead and once you give it a name for the backend pool, so whatever you want to call it. East pool, what's the virtual network has your servers. You pick the 2 servers in SQL 1, you choose the IP address. SQL 2, choose the IP address. So these 2 servers are now in my backend pool. You don't put your file share witness in here because you never want to route traffic to your file share witness. And then we're going to configure the load balancing, what's called the health probe. So health probe, we'll talk about this in a little bit, but as I mentioned, the load balancer needs to know which node is active. So it's going to do this through this health probe. So we're going to probe port 59999. So remember that port, 59999. And it's going to probe every 5 seconds. And after 2 missed probes, it's going to remove that server from the back end so that it doesn't direct any traffic to it. All right, so we did the health probe. Now we're going to add some load balancing rules. So click on load balancing rules. So what traffic do we want to load? Do we want this load balancer to forward? So we want it to forward all the TCP 1433 traffic. So give it a name, choose the protocol, 1433. And yeah. You could forward what's called HA ports, which is like everything. If you're secure with your network, that will work as well. But 1433 is a bit more specific to forward that traffic. Here's the important part right here. Besides 1433, you have to make sure you enable the floating IP for direct server return. So we get that going. So that was the load balancer for the US East. We would do the same thing for the Central for that one server. Not sure if I have that in my demo or not, but you do have to do that for, Central. Same idea. I'm not going to make you watch that again. So once you have all of your load balancers created, then we're ready to jump over and create the listener in, for the availability group. So here's Failover Cluster Manager, and that's the AG that we created. So it creates this cluster object in here, and what we're going to do is right-click on that cluster object and say Create New Access Point or Client Access Point. So we're going to go ahead and give it a name. This is the name your clients are going to connect to. So make sure it's what you want to use. And you notice all DHCP. We're going to fix that in a minute. And view reports. So it created a name, but because again the servers use DHCP, it didn't give you an option to specify a static IP. So we have to go into the properties of this now and fix a couple things. So we look at these. These are the name and IP we just created. So we're going to take a look at this first IP address, and we're going to change it. We're going to change it to static, and we're going to use that 101 address again. So remember, that's the same address we used for the load balancer. So the load balancer and the client listener share the same address. That's a critical piece of the puzzle that you want to remember. Right? So we're going to do that that was the address that was valid for the East subnet. Now we go into this address that's valid for the Central subnet, do the same thing. So we got that. And we're getting there. So we're closer, but there's still a couple more steps before this will work. So make sure we update the static addresses. Bring it online. Now we have to manually set the dependency. So since we added the name, the cluster did not set dependencies for us automatically. So right-clicking on the AG resource and then go under dependencies and add that listener as a dependency of the AG. All right, it's telling me it has to be online before I can do that. So let me bring it online. Do that again. All right, so set the dependency. Again, this is all unique in Azure. It would have been easier if we just created that when we created the AG to begin with. Now, final step, or final 2 steps, really. I'm just copying the name of this network because we're going to use this in a script later. So remember, cluster network 1, I got that out of the networks tab. This confuses a lot of people when they look at this script. And again, this script is in the documentation, so it's nothing that I wrote. It's in the Microsoft documentation. But you have to, the biggest part where people will get fouled up is it's setting some variables, and cluster network name is one of the variables it wants to set. So don't forget that the name it's looking for is right here. The cluster network 1, it's in the networks tab of failover clustering. So you grab that name, paste it in the script. Right there with the cluster network name. The next thing is the IP resource name. And remember, we have 2 IP resources, so we're going to have to run this twice, one for each subnet. So what are they looking for? So again, this is another place where people get fouled up, is they're looking down here. If you look at all the resources under the availability group, you have the name and you have the 2 IP addresses. It's looking for that IP address name right there, IP address 10.0.1.0. So we copy that and paste that in the script. And then finally, the IP listener. So this is the IP address of the listener. So we know what that is. It's the one that ends in the 101. And so what is this script doing? This script is doing 2 things. It's updating the IP address to, so that it's going to respond to the probe, the listener probe, which is the next variable we're going to fill out. Remember, before we set up the load balancer to probe on port 59999? Well, this is telling now for this address to listen on that port. So whichever node is active is going to respond to port 59999, and that's going to help the load balancer redirect the traffic. And so it's doing that. The other thing it's going to do, and this confuses people as well, is if you look at the code, I'm not sure if I'm going to scroll over here or not, but the part of the code, it also sets the subnet mask of this address to 255.255.255.255, and you might think, well, geez, that's not my subnet. You know, why would I do that? And in my mind, and it might not even be true, but I'm thinking because you have 2 IP addresses that are the same, one is on the load balancer, one is on your cluster, by setting the cluster address to that /32, it makes it a host-specific route, so you'll never have any IP address conflict. I don't know if that's the official explanation, but that's what I like to say. But just don't be concerned when you see that it's setting it and think you need to fix it. It's right. Leave it at the 255.255.255.255. So last step is we got to go into the My AG, and this is in SQL Server Management Studio, and we see the 2 addresses. We have to add the port that we're going to listen on for the AG. So that's the 3rd and 4th step. That's kind of different than your usual experience of just creating AGs and listeners all in one step. So make sure if you're doing this in Azure, this is really well documented. Just wanted to point out some of the things that you might not, if you're not reading the documentation closely and you're just like, I know how to do this, and it's not going to work if you think you know what you're doing there. Okay, so back to the presentation. Let's see, we got about 15 minutes, so we'll move fast. So the other Azure HA options. So in SQL Server, it's always been, you got availability groups with SQL 2012, Enterprise Edition and later, or basic availability groups with Standard Edition in 2016, or failover clustering. Now, traditional SQL Server failover cluster instance requires shared storage, which in Azure is not available. In no cloud platform I'm aware of is cluster-aware shared storage available. So you can't normally build a cluster. And if you think about it, if I had shared storage, what availability zone would it sit in? So it doesn't really make a lot of sense when you're thinking about availability across data centers. So the only option when you talk about building a SQL Server FCI, with Windows Server 2016, Microsoft introduced Storage Spaces Direct, which is kind of a storage virtualization that lets you leverage and pool local disk together to leverage CSV and SMB shares. And with I think it's SQL 2016 and later, supports putting your databases on those SMB shares. So you can build a simple 2-node cluster or 3-node cluster in Azure on top of S2D if you're running Windows 2016 or later or SQL 2016 or later. However, one of the biggest limitations with doing S2D is that it does not support cross data center deployments. So you can't deploy them across availability zones, so you're limited to fault domains. And so that gives you the 99.95, not the 4 nines. And there's also not really a great disaster recovery solution for it. So your options are very limited to, even if you build a S2D cluster, to have disaster recovery for it in Azure. The other option they mentioned here, and I won't dwell on it because it's my company, is you can use third-party product to basically do similar stuff to S2D that enables failover clustering using just local disk. And that's why I think I know a little bit about it, because I spend most of my time doing this kind of stuff working in Azure. So let's move forward. I'm not going to do the demo with S2D because, again, I don't think it's really a great solution for those reasons, limited to fault domains and not really having a great DR story around it. And maybe there's announcements in Ignite this week that I missed, but I'm still taking a wait and see option with the S2D for HA. So if you're doing HA, availability groups, third party, or S2D are kind of your options for high availability. Disaster recovery, your options open up a little bit more. Of course, you can continue to use availability groups like we saw and configured. You just put one of your replicas in a different region and you have a real robust disaster recovery with minimal data loss, asynchronous. You're not talking about snapshots that are 15 minutes behind you. You're talking about, seconds worth of data being lost, right? So that's always an option. And, database mirroring, of course, is still in the box. You can do that if you want to get data out. Some new interesting things to do is to leverage blob storage as a backup. And you can do this from instances running in Azure or even instances running on-prem. And so I think I have a quick demo for blob storage backup, because this is, when I first tried to do it, it didn't go so well. And there's a funny Brent Ozar video if you Google this, and we had the exact same experience. So I'm going to walk through this. So again, blob storage is just, an Azure storage, same as we created before. We're going to create an Azure storage account, and then we're going to create a container in that account, and that's our blob storage. The cool thing about blob storage is that if your storage account is geo-replicated, that gives you redundancy. So not only your backups are good, but they're also geo-replicated, so you have some redundancy there for your backups. So we're going to walk through this. Pretty easy to set up, create a new storage account. Again, you put it in a resource group. You got to give it a unique name, the location. Where do you want to, give it a name, and then you got to pick a location where you want to store, where you want the storage account to live. So I'm putting in US East 2. Again, it could be geo-replicated for redundancy. And what I like about this blob storage is you are still in control of your backups. You're not, and we're going to look at like Azure Backup next, which is a backup service, which has a lot more features, a lot more maybe ease of use, but it's still a service, and it has its limits. I think using general backup, and we'll see. This is just basically enabling another backup location for a standard SQL Server backup that's going to be geo-located. And what I like about it is it's your backup. So you can copy that backup to other places, and you can restore anywhere you want to restore. It's kind of like roll your own type backup. So again, creating a storage account. Let's jump forward for sake of time here. There's nothing unique about it. Just create your storage account. Then we're going to go ahead and create a container in that account. So this is the storage account we just created. You see containers in the middle here. So we're going to create a new container, and you're going to have to remember this name. So we're going to use this as part of our backup process. So jumping forward, here's our backup container. This is the URL to access our container. We're going to use this when we create our backup job. So you want to copy that. And you also want to copy the access key of your storage account. And we're going to use that name and the access key as part of our credentials for the backup job. All right, so once we have that information, this is what your backup job is going to look like. Your backup database, HR, you specify the URL. Let's let this run. Yeah. So they see this with credential backup. I think I skipped over that. We create a credential in SQL Server Management Studio before we do the backup that uses that access key. I might have cut it out accidentally, but that's the key part is you have to create a credential that leverages the storage account name and key as so that the backup will work and will authenticate with your storage account. All right, so I'm going to jump forward. So again, that's just leveraging simple SQL Server backup to blob storage in Azure, which then can be geo-replicated. So that's a great option for backups. But then there are some other options. Checking time here. You can use Azure SQL Server. You can use Azure SQL Server DR. So Azure Site Recovery. And let me just jump through here, make sure we cover all the good stuff in Azure Backup. So for sake of time, I think we'll look at the Azure Site Recovery. Yeah. So there's two services you can leverage through the Recovery Services Vault. One is a simple backup utility, almost like a package backup solution you would buy from a vendor. It's got lots of bells and whistles. You can schedule your backups. You can restore from multiple recovery points. It's really nice. The only thing I didn't like about it when I was reading it is when you back up a server, the documentation says you can only restore it to a server in the same region. I'm thinking, well, what if I stored the backups on geo-replicated storage account? How would I ever use that if you're telling me I can only restore it in the same region? So I have a question out to Microsoft at this, around this point. It's like, what happens if I lose that region? My backup solution is no good, or is Microsoft going to light it up in the other region for me? I don't know. So that's really my only concern about using the Azure backup solution. So it's pretty simple, but I'm not going to have time to demo it. Instead, I'm going to demo this Azure Site Recovery, which I think is really slick. If you're not familiar with Azure Site Recovery, it's basically Microsoft gives you the ability to replicate an entire virtual machine, not just the Azure database, but the entire instance from one region to another, or even from on-prem into Azure, lots of different options. So we're talking about replicating from Azure East to Azure Central at the VM level. And it's nice because it's simple, and it doesn't matter what your application is or your operating system. It just works, and for all your workloads. The only, I think, downside would be there's a limited. I think it's, unless they increased it recently, it used to be limited to 10 megabytes per second of churn. So if your rate of change on any given disk exceeds 10 megabytes per second, there's a good chance that Azure Site Recovery is not going to be able to keep up, and your recovery point objective is just going to grow beyond what is acceptable. So as long as your rate of change goes in, fits in that range, you're going to be able to use this. And it's really simple to set up. We're going to just let this run. You create a new Recovery Services Vault. similar to what we saw earlier. The backup, so we'll give it a name. Give it a name. One of the things I should mention, if you're replicating from east to west, you're going to want to, or east to central, you're going to want to create the vault in your DR site. So we're going to create it in central US. If you try to create it in your local site, you're going to get errors, so you can't do that. So create the vault in the DR site, step one. Once the vault's created, you go in here to these, the replicate items, and you choose the source of where the VMs are that you want to replicate. So US East 2, they choose the network they live in, or the resource group they live in. Okay. Choose the virtual machine you want to replicate, or you can replicate a group of virtual machines and put them in a consistency group so they replicate at the exact same point in time, and so they're recoverable from the same point in time. You would do that if you're replicating like a whole AG or whatever. And there's options you can set. How often do I replicate? How long do I want to retain the replicas? I think the max is 24 hours retention. How often do I want to do app consistent snapshots, which will coalesce your database versus crash consistent snapshots. So you choose all your settings, and once you're done, you just click done. It takes some time. I can't remember from the time it actually started, and this was kind of an empty VM till the time it was actually fully replicated. It might have taken an hour because it's got to provision all the resources in the DR site and actually do the initial replication, which will be a full replication. So we are almost out of time, so I'm going to jump forward to the end. And once it's done, you can do, one of the really cool things is you can do a test failover. So once it's fully replicated, through the UI, you can do a test failover and actually bring up that VM in a segmented network so that you don't have name conflicts with your production network. And so you can do a whole test failover without impacting production at all. So it's pretty cool. So we're just about out of time. 2 minutes left. Does anyone have any questions about this? And sorry, I kind of rushed through some stuff. There's a lot of material, and just wanted to give you a general feel for what's available in Azure as far as the infrastructure and how to leverage it, and then give you a taste, a few of the different options that you can use for SQL Server. But in my mind, you're always going to want high availability, so I would say always build some sort of failover cluster or availability group between availability zones in a single region, and have a disaster recovery plan. Maybe backup is fine. Backup is stored in a remote site. It all depends on what your recovery time objective is versus your recovery point objective, how much money you have to spend, and then there's lots of options. So this is just a few of them, and there's a world of third-party options out there. I mean, Azure Site Recovery is kind of like, Zerto's business model, the same idea, but Zerto would be, cover different cloud platforms and whatnot. But there's lots of options out there. So thanks for your attention. I'll be here if you have any questions. I'll be at our Sios booth for the remainder of the expo hall, which I think is 12 or something like that. So I hope to see some of you guys. But if not, thanks for your attention, and thanks to Microsoft for that great review of what was going on behind the scenes. I know I wouldn't want to have been that engineer for those couple days trying to get things back online. It was pretty intense, I'm sure. Pretty intense.
It was more than 1,000 engineers working on that.
Yeah, all hands on deck. Well, good job. Like I said, no data loss, and the important thing is to learn. And I know Microsoft has already made changes. It's like, okay, that was bad. We could do this better. And so there's always, but there's always the next time. It's like, forgot about that, or didn't expect that meteor to take out 2 data centers, or, so you got to plan for the worst. Thanks again.